Alright, hello class that's away. We're going to do this problem together now. So, as you've probably read, alright, you need to have already read the bit that says that Kw, the ionic product of water, is always going to be equal to 10 to the minus 14. Okay, and it's the product of your H3O plus times your OH minus. Okay, so the first question is what's the concentration of H3O plus if we add this much concentration of nitric acid? So, anyone? No? Go on then. Okay, it's the same concentration, right? Because this is what kind of acid? Strong acid, right? So if it's a strong acid, we know that it's a complete reaction with water. So HNO3 plus water completely reacts to make H3O plus what's the other bit? NO3, just a nitrate ion. Obviously you should probably put your state symbols in there as well to be proper about it. Now, once you've done that, if you think about the fact that you've got 5.6 moles per litre here, you're going to have exactly the same produced. Okay, because for every mole, it doesn't matter about the fact that it's per litre, for every mole you're going to get a mole over here. So it's going to be 5.6 as well. Okay, and that's therefore the answer, 5.6. I should sort of do the index as well. I missed that, didn't I? Times 10 to the minus 6. Times 10 to the minus 6. Okay, cool. Right, next bit, OH minus. So this is where you're going to have to use your KW bit. So how do you do it? Yep. Yeah, how do you get there? Yeah, good. So you divide. So first of all, you set it equal to 10 to the 14. So you go, you write it out. Let's do it all by the book. Okay. So you're going to write out the ionic product. So this means concentration of hydronium times concentration of hydroxide equals 10 to the minus 14. Therefore, let's sub in. We know that H3O plus is going to be 5.6 times 10 to the minus 6 times by the unknown. Okay, equals 10 to the minus 14. And now, you just use algebra to solve it. So, you were saying divide by. Yeah. So, OH minus is going to be 10 to the minus 14 over 5.6 times 10 to the minus 6. And what did you get for that? 1.8 times 10 to the power of negative 9. Cool. And that's, what unit's that going to be in? Yeah. Moles. Yeah. Hang on. Yeah, moles per litre. Or just big M, whichever you like. Cool. So that's how you do those ones. So you've got to remember that you have to use the ionic product of water to find out the missing hydroxide concentration.